Okay, class. First of all, I hope you have an awesome long. We'll wait. I hope you have an awesome long weekend, even though I don't get to, and I get to get my class removed. By the way, thanks for everyone who volunteered. There were some students who did volunteer crazily. I got most of it done last night, and so pretty much it's just the desk area and my filing cabinets that need to go up now. So anyways, I'll be doing that for a little bit on Monday anyways, or maybe today. My good news is only 3 out of 87 students are failing AP Stats. And the one is because they've been out for a long time. I'm sure you know who that is. And that new assignments, the B review is up. No, it's not you guys. You're doing fine. All right. The B review is up. Next class, we will do a quiz on probability. So I need you to pay close attention today. This is one of the hardest topics we cover. I have faith in you that you can get this. So several of you gave me what you learned. I learned how to read a tree diagram, and it is actually pretty simple. I was not expecting to see that one. So that's good. I'm glad that person, they like the tree diagrams and they got it down. We are going to practice both tree diagrams and tables and formulas today. All right. So what you struggled with, probabilities, I was supposed to multiply. Am I supposed to multiply or divide or what? Finding if things are independent or dependent and how that links them. Tree stems, really tree diagrams to find probability. I didn't know which stems to multiply for given that. So we're going to talk about what order they come in today. Finding out how to order the stem. So yes. And I figured that's usually the big hang up is which branches do you do first? Very strange. All right. Oh, and there we go. So, you know what we're going to do is we're just going to do the first side. I'm not going to worry too much about the back side on this one. It's nice. I'll go ahead and post answers for the back side for those of you who are curious. Because you're going to have some, this is your extra practice. I'll give you in a sec. But in the meantime, we're going to do taco tongue. And then I will go ahead and show you the important ideas. So I'll post these up while, and share them with you either on the Schoology class sessions and also have them posted here. All right. So okay, I know we had someone in every group record how many people had whatever, right? And so, where are all my purple pens? Okay, whatever. So, how many people were super talented in this corner? 13? Oh my God. There were 13 of you? All right, I think it was. How many were in this corner that could do taco tongue but not evil eyebrow? 12. All right. So there are 25 people on this side of the room. That's actually why I knew that was going to be a big group, and I had an idea that might be a big group. I knew that was not going to be a big group, and I was not surprised that was the tiniest group, because that group over there was nobody, right? Everybody in this room can actually do taco tongue or evil eyebrow. That's not true in all my classes. You're just talented. Oh, no, that's right. You're right. It was over here. Sorry. How many people do we have over there? 6. Oh, I lied. There's 6 people in this room who cannot do either one. Taco tongue is really easy for me, but I don't know about it. Evil eyebrow. He'll do autographs. So we have 13 total that can do evil eyebrow and 12 that can't. Oh, 18. Mrs. Overman can't do any math today, apparently. It's too bad I'm a math teacher. Okay. All right. So there's a couple of symbols you should know. You should get used to the and symbol. That's the and symbol. This is the or symbol. All right. And here's how, this is like union. So that's how I can remember. You bring together, you bring different groups, the things that are slightly different together is an or. And is kind of like the N if I threw did that and threw a thing in front of it, it looks like an N. And there's an N in and. So that's how I remember it. All right. Okay. So the other thing you should do is, if we look at just the inside, we had the 4 corners on the room, right? So we had 4 groups. Now, there was nobody in that group, but that we still had a corner for it. How many blanks do I have on this side? 4. Same thing. So this is actually another way to show a two-way table. So if I was putting a number here, what number should I put there? 12 is correct, right? 12 because they are taco tongue, but they are not in the evil eyebrow. So that would be this corner right here. And then this part is and, where they can do both. There were 13 of you in this far corner that could do both. And then evil eyebrow, but no taco tongue, there were 0 of you. And then we had 6 here, right? Who couldn't do either one. So suppose we randomly choose a student from class. What's the probability? So for this class, if I randomly pick a 7th period stats student, what's the probability they can do taco tongue? 25 out of 31 is correct. Now you see the C here?
It's 12 out of 31.
Wait, is it 12 out of 31?
Oh, never mind, it's 25.
Yeah, it is 25. Why is it 25?
Because
Both of these can do taco. So thank you for reminding, no, seriously, you reminded me. I'd like to highlight that these are marginal distributions. All right, that's called a marginal distribution. You remember when we did the police force, we also talked about marginal distributions there. This is also a marginal for evil eyebrow. I'll just call it EE. So this is marginal as well. When you only have one word in there and you're not adding extra conditions, you can just go to the totals on the margins and that'll give you it. All right. So that is 25 out of 31. And the probability someone can't do taco tongue is 6 out of 31. All right. What's the probability someone can do evil eyebrow? Nobody can do evil eyebrow? I know. 13 out of 31. 13 out of 31. We have some excellent evil eyebrows. Some of the best evil eyebrows I've seen doing this lesson. Very evil. You should pull those out for Halloween, right? Did Dracula do an evil eyebrow? I think so. When the actor, if you saw Dracula, I think he would do an evil eyebrow, right? Yeah, I think Dracula would totally do an evil eyebrow. All right. So we have about 42%, 41.9% of people in this class can do evil eyebrow. Almost half. And almost everybody can do taco tongue at 80.6%. And then there are a couple that can't do taco tongue. I'm using a calculator in case you're wondering. At 19.4%. So if I put those two together, what did they add up to? 100%, right? Because you can either do taco tongue or you cannot do taco tongue. It's one or the other, not both. All right. It's kind of like, you ever heard the saying that you can't be a little bit pregnant? Have you never heard that saying? You can't be a little bit pregnant. You're either pregnant or you're not. So those are, yeah. Same thing with taco tongue. You either can do taco tongue or not do taco tongue. All right, how many cannot? So the C means not. The C means not. All right. You can also write not. So you don't have to use a symbol like a C. It could also be an apostrophe. So I could write it like this. I'll say evil eyebrow apostrophe. That's the same thing. So C and the apostrophe are shortcuts for not. Okay. So not evil eyebrow. How many people can't do it? Looks like 18 of us, including me, cannot do it. All right. Although I'm not in the numbers technically. And yeah, someone says when I try to do evil eyebrow, I pull off more of a blue steel look. Nobody knows blue steel?
Why not Ferrari or Magnum?
Yeah, it would be good. Magnum is good. Yes. But you got to remember, he was working on Blue Steel. Yes. Anyone a fan of Zoolander? Nobody? Zoolander, yes. With a tiny phone. I love Zoolander. All right. Probability of taco tongue and evil eyebrow. Remember, ands are the easiest. So that would be this group right here, right? The 13. Very talented people, these 13 people. They will go far in life. 41.9% of you can do both. You're so annoying. All right. How many of you can do taco tongue but not evil eyebrow? Oh, that's my peeps. There are 12 of us. Our group is almost as big as yours. Divided by 31. I'm putting the decimals for a reason. All right. 38.7%. So some of you, someone who can't do taco tongue but can do evil eyebrow. So not taco tongue and yes, evil eyebrow. This was the only class where there was no one in that category. And then finally, those of you who cannot do either one. So 6 divided by 31. I still love you in the group of 6. You're still my kiddos. All right. So you were at 19.4%. Guess what these add up to? They add up to 100%. Well, where does 41.9% go? It goes right in here. 41.9%. You've probably seen Venn diagrams with percentages in them instead of just plain old numbers. Taco tongue and evil eyebrow, and not evil eyebrow, that's over here, 38.7%. Then we had 0% over here and 19.4% here. So very cool. It's kind of cool you had nobody that was in that category. All right, now remember the OR probability is the hardest probability. So if we looked at people, I'm going to go ahead and highlight in green. People that can do taco tongue or evil eyebrow, that's all these people, right? All these people can do either taco tongue and or evil eyebrow. So that would be 13 plus 12 plus 0 all over 31, which is the 25 over 31, which works out to be 80.6%, right? Is that right? Yeah. Oh, it's so funny because of the 0, I get some matching answers. Now, let me ask you something. Could I just add the probability of taco tongue plus the probability of evil eyebrow and get the right answer? What do you think? Let's try it. What's the probability of having taco tongue? It's 25 out of 31, right? What's the probability of evil eyebrow? It's 13 out of 31. What's wrong? There's something wrong. So that's the probability of taco tongue. That's the probability of evil eyebrow. The 13 is double counting some, right? It's the 13 is in here and in here. So basically, I could have said this, a better way to illustrate this. Let me change that. Thank you, Isabella. You reminded me this is a better way to write it. The 13 right here is being counted twice because it's in this row and that column. So the way we do that is we subtract the overlap. So the way the formula looks like is that you subtract taco tongue and evil eyebrow, and that all works. So that's the OR probability, all right? I can do the same thing here. Probability of taco tongue plus probability of not evil eyebrow, which is putting the funny C on it, minus the probability of taco tongue and evil eyebrow. So taco tongue we said was 13 plus 12 over 31. Not evil eyebrow is 12 plus 6 over 31. And then I subtract out what's in both, which is the the 12, because the 12 is the one being double counted. And it gives me the right answer, which would be a lot. Taco tongue or not evil eyebrow. That's pretty much everybody, isn't it? 31 over 31. Yes. All right. Suppose now one more probability to show you before I give you your chance to earn your 5 bonus points. Taco tongue, and then we have a funny line. Evil eyebrow is read as taco tongue given evil eyebrow. Now we already talked about this given. This tells you your new total. All right. So the way you can do this, this is number who can do taco tongue and evil eyebrow divided by just the people who can do evil eyebrow. All right. So how many can do taco tongue and evil eyebrow is 13. Right? And then divided by the number of people who have evil eyebrow, guess what? It's 13. In this class, it's very interesting because it's 100%. So if you were able to do evil eyebrow in this class, you definitely could do taco tongue. All right. Now, this one is given taco tongue, given not evil eyebrow. All right. And so I'm going to show this to you another way too. So taco tongue and evil eyebrow was not evil eyebrow was 12, but this one had a bigger total for not evil eyebrow. It was 18. So it's about 66.7%. So the total comes from the given. All right. Total comes from the given. Class. Chromebooks closed. Phones put up. Out of my sight and yours for the phones, not on your table. Switch, pause. I know you don't have to save. I know how Switch works. Thank you. All right, so let me walk through this. You should have this. So what we did here is this is the data from seniors at Status High School, all right? So we're looking for probability of taco tongue. That's the second page on the taco tongue evil eyebrow. And we got, if you're doing the probability of taco tongue, notice, what did I highlight in pink? What did I call that? Marginal distribution, right? So I'm just looking at the total individual totals for taco tongue. That's all I need to look at, right? So there, the probability of taco tongue was 480 out of 600. That's how we got 0.8 there. I still see Chromebooks open, Buds out. I need you looking at the board. Table 5 or table. I think it is table 5. Yes, thank you. All right. So then we look at probability given yes evil eyebrow. So I kind of circled yes evil eyebrow here and then circled yes evil eyebrow there. So when you have it given, that means you're only in that world on the table. We can ignore the no evil eyebrows. All right. So the probability of taco tongue here is just the 180 out of 200, which is 0.9. All right. And then finally, we said the probability of taco tongue given they couldn't do evil eyebrow. Well, there are 400 people who couldn't do evil eyebrow. And out of those, 300 couldn't do it. The 300 could do taco tongue. So 300 of these kiddos could do taco tongue. So that's 0.75. Now, I probably should add the comment there that taco tongue and evil eyebrow, are they independent? Yes or no? Based on that. Correct. Why? So if you looked kind of like what I wrote on the math chart just now while you guys were relaxing, which is fine, I'm not complaining. Let's pull that back up. What did I say? If A and B are independent, first of all, I should be able to multiply them. That's one rule. But if you're trying to compare, The probability of taco tongue should equal the probability of taco tongue given evil eyebrow, which should also equal the probability of taco tongue given not evil eyebrow, right? So it shouldn't matter if you have evil eyebrow or not to affect the probability of being able to do taco tongue. Okay, so let's see, where's my, move that out. So back to this. Those are not the same. 80% is not the same as 90%. So they're not independent. This next table was tricky. So if things are independent, really all those probabilities should be what? 80% for taco tongue, right? Because overall, the probability for taco tongue was 80%. So it shouldn't matter if you're evil eyebrow or not. So how many evil eyebrow people do we have? How many evil eyebrow people do we have? 200, right? What's 80% of 200?
160.
160. That's where I got this right here. See all that? Okay. Then I said, okay, and also 80% of these 400 should be able to do taco tongue. And then how did I figure out the numbers in blue? I subtracted them from the total. It's a complement, correct. So if I have 200 and 160 have taco tongue, then 40 don't. If I have 400 and 320 have taco tongue, then 80 don't, all right? How are we feeling on the table? Thumbs up, thumbs down, thumbs sideways. All right. And the reason I chose 80% is that was the number that I started on 6A. That's where I pulled that number because it wasn't a conditional probability. It was just an overall. So now if we compare the probabilities here, right, we have probability of taco tongue given, or just probability of taco tongue is still 480 out of 600. It's still 0.80. No reason for it to change. But now the way I changed the table, probability of taco tongue given evil eyebrow is 160 out of 200, right? And then the probability of taco tongue given they don't have evil eyebrow is 320 over 400. But all these probabilities are the same. Okay. So what do you notice about your answers in 6 and 8? In number 6, all the probabilities are different. In number 8, all the probabilities are equal. So how do we generalize? This is what I had, and Saket was asking me about this. He says, well, you have something else written under independent. Well, when things are independent in probability, it has a couple of properties, not just one. This is one of the properties, all right? The other property is that you can just multiply. If you want the probability of A and B, just multiply probability of A times probability of B. Then we got some additional practice on back. There are the big ideas, right? And I'm pretty much explaining that formula, A given B. And when knowing one event has occurred or has not occurred does not affect the probability of the second event, then it's independent, which is what we had written on the math charts, okay? Then on a check for your understanding, what we did is, given that the mother was surveyed in 1976, this is the first one, so I just look at 1976, and what's the probability she has 40 plus children? It'll be 40 out of 100. Given the mother was not surveyed in 1976, well, then that means I have to look at the other two columns, and the probability she has 4 more kids is you got this one, and then over 200. And then the question is, are they independent? Are those probabilities the same? No. So they're not independent. All right. See how I said probability of, what was C? Children given, let's see. I don't know how they pick C and S. Surveyed. Yeah, surveyed and children. 4 or more children. So probability of 4 or more children given surveyed and probability of 4 or more children given not surveyed in 1976 are not the same, so it's not independent. And that's it. Okay, how are we feeling now? So you can take the quiz without me on Friday. All right, there will be some. You are welcome to,